Let's kick it up a notch with solving sine and cosine functions. Let's look at all the transformations like you learned them in college algebra. We're looking at stretching and shrinking. We're looking at shifting to the left and to the right and up or down. So I basically wrote down here the general form of any sine or cosine functions with all the possible transformations. A is the amplitude. That tells us if we are stretching or shrinking. Stretch, shrink. The B by itself is the period. B represents actually to find the period. B, 2 pi over B gives us the period. B is not the period. Now, Bx minus C is our phase shift. Phase shift to the left or to the right, depending on what we have here. And this last D tells us if the function is moving up or down. So D at the end, we're going up or down. If it's positive, we're going up. If it's negative, we're going down. The parentheses Bx minus C tells us if we're going to the left or to the right, and I'm going to show you a problem later. B is our value we need to find the period if it is not 2 pi, and A is the amplitude. So here's a problem that's actually out of the book on page 304, number 7. Let's take a look at this problem and see what we match it up with the general form and see what we got going here. We have cosine of 3/4 cosine of pi halves x. So we definitely are not going up or down here with this problem. We also don't have a phase shift to the left or to the right. So that just tells us that this problem is starting at 0. Now, we have an amplitude here. The amplitude is 3/4, and B in this case is pi over 2. B is the coefficient in front of the x, and B, we need to find the period. So the period is 2 pi over 2. Let's do some fraction action magic. 2 pi times, we need to flip, times 2 over pi. We can clearly see that the pi's reduce, and our period in this case is 4. It is 4. We do not have pi anymore. That's kind of nice, period. The period is 4. The x increments we find by multiplying 4, the period, by 1/4, again, because we have 5 key points, but there are 4 distances in between. So the x increment, which is really nice, is 1. So we're starting off with 0. That's right here. Then our next increment, we said it's 1, so we keep adding 1 to it, 2, 3, and we end at the end of the period, which in this case is 4. 0, 1, 2, 3, 4. Okay, our amplitude is 3/4, and we are having a cosine function. Maybe here on the side you want to have a little basic cosine function. It starts with 1, it goes to 0, it goes to -1, it goes to 0, and goes back up to 1. So these are kind of my y values for the basic cosine function. I use those and multiply by 3/4. So I get 3/4 here, then I go to 0, Then I have negative 3/4. Then I go to 0 and go back up to positive 3/4. Okay. 3/4, negative 3/4. So we start at 0, 3/4. Then we go to 0, negative, back to 0, and back up to 1. So that is one period of this particular function. Now, if the book says to draw 2 periods, well, my increments are 1, so 5, 6, 7, and 8. I can also go to the left, negative 1, negative 2. So we go back to 0, then we go back to negative 3/4, back to 0, and back up to positive 3/4. Young. This is now 2 periods. Beautiful. Oh, I like graphing. If you go the other way, you go down, back to negative 3/4, and at least we can get half a cosine function in there. That's how you graph functions with more than one transformation. Let's take another function. This is a sine function, and this sine function is beautiful because it has all the transformation. It would be even better if the amplitude wasn't just one. But we're definitely going to the left or right here. We're going up. We got it all. So let's write out what is going on here. The amplitude, A, in this case, is 1 because you don't see a value here. That means automatically it is 1. B, we need for the period, is 3. So based on that, we can find the period. The period, again, the formula is 2 pi over b, so our period here is just plain simple 2 pi over 3. 2 pi over 3 units is 1 full period. Now our x increments, 1/4 times 2 pi over 3. Let's do some reducing action here. And we would get 2 goes into 2 once and into 4 twice. So that is pi over 6. Okay. So we got our period, we got our x increments. We know that our amplitude is 1, but we also have a transformation here. We're going up 1 unit with our y value. So let's put a 2 here as well and a negative 2. Okay, this is a phase shift, the parentheses. So to get our starting point, we set the parentheses, the start of this graph. We set the parentheses 3x minus 3 pi over 4 equal to 0. Why equal to 0? Because the basic sine function starts at 0. So we got to get a new starting point. So of course you solve this one for x. 3x, bring the 3 pi over 4 to the other side, is 3 pi over 4, and then you divide by 3, which is the same as multiplying by 1/3. So our start of this lovely sine function is 3 pi over 12. Okay, so somewhere over here, let's just make it here. 3 pi over 12 is our starting x value. Let's see if we can put the 5 key points, 3 pi over 12. Okay, now what is the y value? Let's take a look at the basic function. The basic function starts at 0, 1, 0, -1, and it goes back to 0. Since our amplitude is 1, however, we're moving up 1 unit, so 0 plus 1, our corresponding y value is 1. So whatever transformation you have at the end, that's what you have to add to the, if we have an amplitude other than 1. So in this case, we have 1. Now, to find the next point, we have to add our increment. Our increment is pi over 6, but I have a denominator of 12. So I should maybe have not reduced it. If I keep it at 12, it's 2 pi over 12. So that's what I'm going to use. I'm going to add 2 pi over 12 here, and that gives me my next point, which is 5 pi over 12. 5 pi over 12, our next value in the basic sine function is 1 plus 1. So here we would get a 2. Then, so 5 pi over 12 plus 2 pi over 12 is 7 pi over 12 plus another 2 pi over 12 is 9 pi over 12, and I would really keep it as denominator of 12 plus one more, 1, 2, 3, 4, 5. Oh no, we're starting at 3 pi. Don't start at 0. Here we go. 1, 2, 3, 4. I knew we needed one more. 2 pi over 12, which is 11 pi over 12. There you go. Okay. So where are we? 7 pi over 12. We have a 0 again, plus 1 is 1. 9 pi over 12. -1 plus 1 is 0. And then we have a 0 with 11 pi over 12. That's where our first period ends. Plus 1 is 1. Okay, so let's graph this. 3 pi over 12 is 1. Then we go to 2. Then we go back to 1. Then we go to 0. And we go back to up to 1. So 1 now is really kind of, if I make a dashed line here, my new axis. So if I graph it, we are starting at 1, we go up with a sine function, then we go down all the way to 0 in this case, and we come right back up. Here you go. That is your sine function, not only shifted to the right, 3 pi over 12 or pi over 4. We could have reduced it, but we didn't. And then we're also moved up 1 for the y values. So be careful about that. The way I usually do it, I put my basic y values here on the side, and then depending on what this transformation is, moving up or down, and the amplitude, that's what I'm adding to these basic functions. And that's how you graph a sine or cosine functions with transformations.